People often equate luxury travel with private jets, stretch limousines, and luxurious sedans. Luxury buses and vans don't even cross their minds. There are a lot of luxury buses out there, but what catches our eye is none other than the luxury buses manufactured by Daimler-Benz. What makes these German-manufactured buses so special? Why are they considered one of the best luxury buses out there? Let's find out. Daimler AG is a German automaker and well known for its Mercedes-Benz brand. The company is also popular for making trucks, motorcycles, and buses. The original partnership of Daimler-Benz was formed in 1924 and is today located in Stuttgart, Baden-Württemberg, Germany. As of 2019, the company is ranked by total unit sales as the 10th largest auto manufacturer in the world and earned the top spot as the largest truck manufacturer. Daimler AG owns outright or has financial interests in several auto, truck, bus, and motorcycle divisions outside of its own principal brand, Mercedes-Benz. Among these other brands are Freightliner, Smart Automobile, Thomas Built Buses, Western Star, Setra, Mitsubishi Fuso, MV Agusta, Denza, Beijing Automotive Group, and Renault-Nissan Alliance. Like other auto manufacturers, Daimler has focused some of its efforts at sale in emerging market economies, particularly the BRIC countries, Brazil, Russia, India, and China. Daimler briefly held a substantial interest in Tesla, but sold its stake in the company in 2014. Mercedes-Benz produces vehicles that set standards in terms of safety, quality, and future-proof technologies. Proven overall cost-effectiveness, sustainability, environmental compatibility, and professional business partnerships are the main focus. These are the hallmarks of Mercedes-Benz. Mercedes-Benz has been producing buses since 1895 in Mannheim, Germany, which is now owned by Daimler AG. So how are these top-class automobiles made at its superfactory? A software control gives a command translated into the Cartesian plane motion of the robotic arms. The coaches are painted in an enclosed chamber to avoid paint defects and protect from harmful fumes. Painting involves the application of various coats, varying from phosphate layer to paint and underbody anti-stone chipping layers. These layers are responsible for the longevity of the panel by providing anti-corrosion and damage protection. Drive axle assembly is lifted with a 3-point crane for assembly to subframe along with suspension components. It comprises differential, brake assembly, bearings, and lubrication all in one housing. The subframe is placed on the fixture using a suction pad and rubber suspension springs are mounted. Locating pins for the drive axle assembly are press-fitted in the subframe by hammering operation. The mounting bolts act as guides and help to place the axle on the subframe locator pins. Bolts for the assembly are tightened but not finally torqued by hand due to large torquing values. A battery-operated equipment mover is used to pull the trolley with the subassembly. Hydraulic lift is used to lift the subframe assembly to mount with the coach body. The ease of assembly and cost-effectiveness enables the use of 3-point cranes and handling powertrain components. The automatic transmission system used in the coach has planetary gear sets, controlled clutches, and a torque converter. A pneumatic limiting torque gun is used to torque the bolts of the transmission to the engine. The compressor for bus air conditioning can compress the refrigerant ranging from 19 to 28 bar. Bolts difficult to access are tightened with a universal joint hex head tool. The Blue Efficiency Power engines OM470 and OM471 are 12.8 liters 6 cylinders. The powertrain is carried on a fixture which is towed by an electrical machine with a handlebar. All components are assembled on the coach body on a movable railed fixture. An electric tow tug is used to move the body on the rail for powertrain assembly. The engines have an integrated starter generator which can recover kinetic energy during braking. The powerful 6-cylinder engines impress with outputs of between 265 kW and 350 kW. An electro-hydraulic lift is used to lift the powertrain to fit on the mounts on the body. Driveline assembly such as the cardan shaft is assembled using a UV joint. Coaches are assembled on an assembly station having working areas on elevators. The coach is held on a fixture that supports the drive axles which can move in a rail. The electric level control adjusts vehicle height due to uneven weight distribution. The luggage shelf capacity varies from 9.9 to 12.1 M3 in the Turismo variants. Long hoses, harnesses, and pipes are connected with the help of a plastic adapter at equidistant intervals. An overhead moving gantry allows the insertion of long pipes inside the coach for assembly. The headlights in the lighting systems are movable and change direction according to turns. The headlights are mounted on the front fascia, which is held on a fixture with clamps. The lamps are snap-fitted on the front fascia and then tightened using fasteners. The headlamp assembly consists of a luminosity source, a reflective surface, and a glass lens. A battery-operated torque gun is set to low torque for tightening the small fasteners. The rear light acrylonitrile butadiene styrene panels are snap-fitted on clip towers. A team of operators prepares the window glass by applying a cleaning agent on the surface. Operators flip the glass on the concave side for easy assembly to the body. The glass holding stands have rubber supports to avoid any damage to the glass. A triangular urethane bead is applied with the gun on the body for pasting the glass. A suction manipulator is used to lift the glass windows for pasting to the body. The triangular bead avoids trapping air and makes the seal watertight. The edges have protection tape for protection against injuries. The suction of the manipulator is controlled, which is directly proportional to the weight of the glass. The characteristic line plastic and the Setra name tag are pasted on the body panel. Setra buses are under the umbrella of EvoBus, which is owned by Daimler AG. End-of-line inspections such as gaps are checked with a feeler gauge. A level gauge is used to check panel offsets, if any, for the front bumper and fascia. The Citaro tag is pasted, and finally, assembly checks for the powertrain compartment are made. Hydraulic dampers are used for the powertrain cabin and the luggage cabin lids. The Citaro buses have an electric hybrid and natural gas versions for various transport applications. The operators carry a final inspection of the luggage compartment lids and the dampers. The panel reinforcement welds for the lids and the luggage compartment lights are inspected. Buses are driven out of the facility to the stockyard for distribution to the showrooms. Daimler buses are said to provide all-electric coaches by 2030. At the end of this decade, Daimler buses intend to offer all-electric coaches with its Mercedes-Benz and the Setra brands. To accelerate development, Daimler buses have announced to team up with research institutes and experts from the industry to form the Electrified Coach Project. The project is funded by Germany's Federal Ministry for Economic Affairs and Climate Action. The goal of the Electrified Coach Project is the development of a modular drivetrain and 2 emission-free and practical demonstration vehicles in the next 4 years. They will then be tested under real operating conditions. According to a report by Interact Analysis, 74% of coaches are estimated to be non-electrified in 2030 in the EMEA region. City buses with an all-electric drive, such as the Mercedes e-Citaro, are now a familiar sight on the streets of many German and European cities. Daimler buses sums up requirements for long-range transport, flexibility in use, battery charging on the go, high payloads, and the space for passengers and the luggage are indispensable and in part contradictory. No bus coach manufacturer has yet succeeded in developing a battery-powered coach that can cover workable ranges as well as availability for a wide variety of operating conditions. Daimler Buses is the coordinator of the publicly funded project. Project partners are the Karlsruhe Institute for Technology KIT, University of Mannheim, Technical University of Kaiserslautern, and operator Flix SE with its Green Flix long-distance coaches. Partners will take a holistic approach to the ELCH project. First of all, a modular drive system with a view to energy consumption, range, driving performance, and battery service life will be examined in the concept phase in a pilot project. Synergies with components from the Daimler Truck division will be taken into account. In the second step, factors such as overall costs, environmental impact, and possible integration into existing operating concepts of bus coach companies will be incorporated into the results. Based on the concept evaluation, 2 prototype drivetrains will then be developed and integrated into the demonstration vehicles. This will enable testing under real operating conditions. The findings from the construction of the demonstration vehicles will form the basis for the planning of cost-effective production and assembly processes for electrically powered coaches. This, in combination with the modular product approach, will enable a fast production startup. The profitability of the resulting vehicle concepts will also be assessed from the operator's perspective and taken into account in the concept definition. The objective is to identify cost-efficient concepts for individual vehicles and entire fleets of electrically powered coaches for the various operating profiles. The Mercedes-Benz, as always, delivered unquestionable value and unsurpassed style. Its value proposition is a combination of German engineering and international flair that meets the needs, demands, and desires of luxury buyers around the world, and it will surely do so in the future. What do you think of these luxury buses? Are they worth the hype? Let us know in the comments.